Welcome to another episode of How to Geometry, where I cover some of the basic geometry topics. In this particular video, I'm going to cover what's called the angle of elevation and the angle of depression. And we're going to use these two topics to try to find some unknown distances between various objects. So let's get it. Okay. An angle of elevation and an angle of depression are very, very similar in definition. The difference between the two are the underlying parts, right? So the angle of elevation, it's an angle that is formed by a horizontal line and the line of sight to a point that's above the horizontal line. So looking at the picture, the angle of elevation from the tower, right? So you always want to see the horizontal line, and the angle of elevation, it's the angle that is formed between the horizontal line and the line of sight to a point that's above the horizontal line, right? So from the tower's perspective, they're looking up at the plane, right? Because the plane is definitely above the horizontal line, right? Like eye level to the tower, and then your eye level to the tower, and their line of sight, because they're looking up, right? They're elevating their eyes to look up. That creates an angle. So, hence the name, right? Angle of elevation. So it's an angle, right? Angle of elevation is not a line. It's the angle that is formed between two lines. Which two lines? The horizontal line and the line of sight to the point, right? To the point above. Angle of depression, very similar. It's the angle that is formed by the horizontal line and the line of sight to a point below the horizontal line. So here's my horizontal line with the airplane, right? It's eye level with the airplane. There, the pilot, from the perspective of the airplane, is looking downward, right? Depression. And now that angle that's between the horizontal line and the line of sight, angle 2, is the angle of depression, right? Because the point that's below the horizontal line is definitely the tower. So angle of depression, angle of elevation. That's really it. That's what they are. So now we can use this, right? We can use this to solve problems. You might want to note that if we notice, right, that the angle of elevation, so we'll keep consistent with the colors. So the angle of elevation and the angle of depression form alternate interior angles, right? They're inside the horizontal, cut by a transversal, right? So they're alternate interior. Since the horizontal lines are parallel, then that means that alternate interior angles are definitely congruent. So we're going to use this. So let's look at some identification first. So we want to classify each angle. So from the perspective of the tree, angle number 1, this is definitely angle of depression, right? Looking down, right? So there's the horizontal line, and then the perspective of the tree, top of the tree, looking down, it creates an angle below the horizontal line. From the perspective of the man, looking up at the tree, right? He's looking up, so that's definitely elevation. And now, same man looking down at the base of the tree, this would be depression. I'm color coding it, but right, this is depression. 3 is depression. 2 is the only elevation right now. and from the base of the tree looking up. So here's the horizontal line, the ground, looking up. So this creates elevation, an angle of elevation. So this is identifying. So it's all about that horizontal line. Are you looking up or are you looking down? Below the horizontal. Okay. All right. And this is really going to be all about drawing a picture, right? Can you draw an accurate representation of what they're saying? So at a point on the ground, 50 feet from a tree, the foot of a tree, the angle of elevation. So angle of elevation, that means I'm looking up. So here's my angle of elevation. To the top of the tree is 53 degrees. The top of the tree is mentioned that it's 50 feet tall. We want to find, I take that back. It says that at a point on the ground 50 feet from the foot. Okay, so 50 feet is going to be down here. And then we want to find the height. So it's the unknown. So we'll just call it X. Okay. Given our handy dandy acronym, SOHCAHTOA, right? It's a way of gathering our thoughts and helping us remember which ratios go with which trig ratio. From the perspective of 53, X is opposite, so it's op. And 50 is going to be adjacent. So opposite and adjacent. That's definitely TOA, tangent. So tangent of 53 is equal to opposite over adjacent. So X over 50. Because 50 is in the denominator, we're multiplying both sides by 50. 50's cancel on the right, isolating X, that's what we wanted. And we see that X is equal to 50 times tangent 53. So we go to our calculator, ensuring it's in degree mode, and we'll round to the nearest foot. So this is going to be, so X is equal to 66 feet. Okay. From the top of a lighthouse. All right. So let's test out our skills. So lighthouse, that has to do with the water. So here's my lighthouse. 210 feet high. The angle of depression of a boat is 27 degrees. Okay, so out here in the distance, there's my boat. And angle of depression, right? So that's looking down. I have to be looking down at something. I'm looking down at the boat. So horizontal line, looking down, creates 27 degrees. Find the distance from the boat to the foot of the lighthouse. So again, this is X, right? The foot of the lighthouse to the boat. So you have to be smart enough to know that this is a right angle, right triangle. And we can apply trig here. So I don't want to use 27. I do want to use 27, but not in the manner of where it's placed right now. We just learned, right, that alternate interior, we know that alternate interior angles are congruent. And we know that the angle of depression and the angle of elevation are alternate interior angles. So that means this angle is 27 degrees. Now I could find the complement, right? 27 minus 90 minus 27, and I could figure out this angle up here. But, why? Why? So from the perspective of 27, 210 is opposite, and X is adjacent. So of our three sine, cosine, tangent. Opposite and adjacent is going to be tangent. Is it always tangent? No, it just so happens that it's tangent again. So tangent of 27 is equal to opposite 210 over the adjacent side, which is x. Okay, here x is in the denominator. So when x is in the denominator, we can't multiply by 210 because 210 is already in the numerator. It's not going to cancel. You can't do that. What we can do is swap x and tangent. What I'm saying is x is equal to 210 over tangent 27. Right? You're just swapping x for tangent 27. And this is calculator work. 210 divided by tangent 27. Taking it to the nearest degree, or not nearest degree, this would be nearest foot, we get 412 feet. 412 feet. Okay, next example. An airplane rises vertically 1,000 feet over a horizontal distance of 1 mile. Okay, so what is the angle of elevation of the airplane's path? Okay, so let's see what's happening here. So let's think about what's happening. You have an airplane, and as he's taking off, right, as he's taking off this direction, he's rising, right, he's going up vertically 1,000 feet. So, right, this is I don't know what kind of airplane this is, but there it is. It's the airplane rising 1,000 feet over a horizontal distance of 1 mile. So this is 1 mile, and that's in feet. Okay, we're going to do some conversion here. I already don't like this. So what is the angle? All right, so right there, what is the angle? This is telling us, like, words mean things, and these words are telling us something very specific, that we need to use inverse trig. That is the only tool in our mathematical toolbox that locates an angle, that finds an angle. There's no other tool available to us. Inverse trig is by far the tool. So we need to use inverse trig. So we can call this angle, we can call it theta, right? Theta, the Greek letter that is reserved for angles, specifically angles. It's a variable. Across from theta is 1,000, so this is opposite. Next to theta is 1 mile, so this is adjacent. So opposite and adjacent. And it just so happens this is tangent again. Okay. We can't use feet and miles together. I want to say 1 mile is going to be 5,280, or is it 5,820? It's one of those two. It's worth a Google. Okay, so it's 5,280 feet in a mile. Okay, I want to take tangent inverse, because we said we were looking for an angle, and inverse trig is the only thing. And we've established that in reference to the angle, that 1,000 is opposite, the mile is, or in this case, 5,280 is the adjacent side. So opposite and adjacent has got to be tangent. It's the only one. And because it's looking for an angle, it's inverse. So that's the -1 exponent. It's not a -1 exponent, it's inverse. And of opposite over adjacent. So normally we would say tangent of whatever angle is opposite over adjacent. Now, because we're using the inverse, the opposite over adjacent has to go inside the parentheses. That's what we're taking, so this is going to be 1,000 over 5280. All right, we'll take it to the nearest degree. So this is going to be inverse tangent. 1,000 over 5280. So nearest degree would be 11 degrees. So 11 degrees is the angle of elevation of the airplane's path. Okay, so Richard's flying a kite. All right, so here's Richard flying his little kite. The kite string makes an angle of 57 degrees with a line parallel to the ground. Okay, so we know ground looks like this. The horizontal line looks like this, and makes an angle of 57 degrees. So elevation, right? So it's from the horizontal up. So 57 degrees. If Richard is standing 100 feet from the point on the ground directly below the kite. So this is going to be 100 feet. What are we looking for? Find the length of the kite string. So the red line, X. Okay. From the perspective of 57, what two sides are we dealing with? We're dealing with the hypotenuse and the adjacent side. So adjacent hypotenuse, adjacent AH. So toa. So AH. The cosine. So cosine of 57 is equal to adjacent side over hypotenuse side. So adjacent is 100 over the unknown. Because the unknown, x, is in the denominator, we can swap x and the cosine of 57. So x is equal to 100 divided by cosine 57. Right? If you don't like this, right, you're like, why are we switching? It's because we can multiply both sides by x, and then we can divide both sides by cosine 57. So the x's cancel on the right, and we have 100 over cosine 57, because on the left, the cosines cancel each other out, and we're left with just x. So instead of doing this every time, right, we learn from it, and we say, okay, when the variable is in the bottom, I know I can just switch the x and the cosine term. We go to our calculator, because x is isolated. We want 100 divided by cosine of 57. And we're in degrees, we are. So this will be to the nearest degree. Actually, it's not a degree. It's the kite length. So the length is going to be approximately 184 feet. Okay, last example. The last one's always a doozy. So an observer in a lighthouse is 69 feet above the water. So here's the lighthouse. It's an odd looking lighthouse, but 69 feet above the water. He sights two boats directly in front of him. The angle of depression to the nearest boat, so here's the horizontal line to where he is. So depression would be between the horizontal line and line of sight. So 48. The angle of depression to the other boat, do a different color, is 22. So 48 and 22. What is the distance between the two boats? Okay. I like this one. I like this one a lot. Okay, so let's figure out the nearer boat first. Okay, so this is going to be 48 because why? Why do you think? Because alternate interior angles are congruent, right? And the angle of elevation is equal to the angle of depression from the 2 points. So this is going to be the first unknown distance. So from the perspective of 48, 69 is opposite and x is adjacent. So this is going to mean, this is going to be opposite over adjacent, which is TOA, tangent. So tangent of 48 is equal to opposite over adjacent, 69 over x. We can swap tangent 48 and x, right? Because x is in the denominator. So 40 tan 48 can go in the bottom in place of x, and x will come up. So x is equal to 69 tangent 48 divided by tangent 48. 62 feet. Okay, so this first distance is 62. Okay, let's find the second distance. Second distance. Again, this angle is 22 degrees because the angle of depression matches the angle of elevation. And now I'm going to use x again, right? Well, do I want to use x? We can use something else. We can use y. So this is going to mean that, again, 69 is opposite. So tangent of 22 is equal to 69 over the unknown, right? The unknown distance from the base of the tower to the boat. We're going to swap calculator, 69 divided by trig, tangent, I'm using the inspire, by the way, 22. This is going to be approximately 171. So 171 feet. So from the tower to the first boat is 62 feet. From the tower to the other boat is 171 feet. So we want the distance between the two boats. So let's take the difference. 171 minus 62. Okay, so it's 109 feet. 109 feet between the two boats using trig. It's kind of interesting. Okay. Hopefully you found this video useful. If you haven't done so already, please subscribe, like, comment, let me know what you think. I enjoy reading the comments. So I'll catch you in the next video.